This lesson is going to be called Derivatives the Short Way, and it's because the limit definition of a derivative is the longest possible way to do this. It's a much better way if I give you a function like g of x equals 5x plus 8, or any function that's linear. You might have noticed the derivative always turned out to be, just like from Algebra 1, the number in front of the x. And that's true for all linear equations that are of this form. The derivative works out to be the number in front of the x. So if I say y equals 8x, and I say what is the derivative of that, the answer is 8. You don't have to put that in the limit definition. Or if I say y equals negative 16t, then the answer is negative 16 for the derivative. So that's easy. Also, you might have noticed that back in Algebra 1, if I had y equals 8, that's a horizontal line. The slope of a horizontal line is 0. So y equals 8, y equals pi, y equals anything is a horizontal line. Slope is 0. So that's why the derivative of this, if you split it up with your derivative rules, derivative of 5x is 5, derivative of 8 is 0. So the derivative of all this together is 5 plus 0, or just 5. So there's a rule called the power rule, and the power rule makes life much easier when you're doing derivatives. So let's say I have a function, and you want to take the derivative of this function. All you have to do is bring the exponent down to this number, so 2 times negative 16 is negative 32. Rewrite the x, knock 1 off the power, and that's it. That's how you do the power rule. So this has an x to the first power. That's why a minute ago I said this slope would be 2. That's because 1 times 2 is a 2. And if you rewrote the x and knock 1 off the power, anything to the 0 power, this just makes 1. So that's why 2 times 1 is just 2. That's why that worked even on those. So the derivative of negative 16x squared plus 2x minus 6 is negative 32x plus 2. Or maybe I might say x to the negative 2, which is 1 over x squared. In other words, I could present that to you either way and ask you to find the derivative of this. Well, if I told you in a function that was already in the form of a power, then all you have to do is execute the power rule, which is bring the 2 down, the negative 2, rewrite the x, take 1 away from the power, which negative 2 minus 1 is negative 3. That's it. If it's in 1 over x squared, you have to first convert this to a power, and then execute the power rule, which is to bring the power down, rewrite the x, take 1 off the power. It's traditional to not leave exponents in a negative form, so this answer would convert back to negative 2 over x cubed. If you're not good with these exponent rules, there's a video in the pre-calculus section over exponent rules. You may remember that there were functions that look like this. This actually fits under the power rule because you remember that this can be converted to x to the 4/3 power, and under this case the derivative would be given by bring the power down, 4/3, rewrite the x, take 1 away from the power, 4/3 minus 3/3 is 1/3, and so this would be the derivative. It's traditional to convert this back to a radical if the question was posed as a radical, so you would want to say 4/3 times the cube root of x, or 4 cube root of x over 3. So that is how you do the power rule with derivatives.